Okay, let's quickly see DBMS assignment number 7. Question 1, we are given a schedule S and we have to find out whether it is conflict serializable or view serializable or both. So for this type of question, we have to make a precedence graph. To make a precedence graph, start from the top of the schedule and check which is the first operation. Here T2 has the first operation, draw T2, and since T2 reads from X and T3 writes on X, T3 must be after T2. And when some operation is after some transaction is after some other transaction, it should have an error. After that, check if any other transactions do read or write on X. Now T4 also does read write on X, so T4 should also be done after T2, but T3 will be done after T2, so T4 must be done after T3. So likewise, T4 should be done after T2 and T3. Now T3 does a read operation on Y and T1 also does a write operation on Y. So T1 must be followed after T3. And since T5 also writes on Y, T5 must be done after T1. Now in T1, after Rx, there is Rx and Wx in T4, hence T4 must be performed after T1. Now since there is a vertex T2 which has in degree equal to 0, in degree, that is number of arrows coming towards the vertex equal to 0, that means that this is conflict serializable, and every schedule that is conflict serializable is also view serializable. All conflicts are view serializable. Question number 2 is also similar. We have to identify this time we have to identify the correct sequence. For that, this type of precedence graph will be drawn, and here you can see that T5 has integer equal to 0. So by topological sort, we will always remove the vertex which has integer equal to 0. So once we remove T5, we will write T5. After that, T4 will have integer 0, then T4 will be removed. And from the options, you can see there is only one option that follows this sequence, that is option number B. For this, the correct option is both conflict and view serializable. Question number 3. Now we are asked to find out the number of conflict serializable schedules for the schedule S. Here we again have to draw a precedence graph which will look like the given one. First of all, we have to check that graph has no cycle, that is it is acyclic, and then that means that the given schedule is conflict serializable. And here also you have to see which vertex has the integer equal to 0. There's only one vertex, hence there will be only one unique path that will have a schedule, hence it must start from T1, hence that is the only one path. Now we have to find out possible number of view serializable schedules. To directly check if a schedule is view serializable, we have to check that the schedule must end with the transaction that has been finally updated. In the given schedule, you can see that T3 is the final transaction that does some writing operation, hence T3 must come last, and from T1 and T2 we have to figure out the order. In this case, T1 is the initial transaction and it reads on X, and T2 writes on X, hence T2 must come after T1. Similarly, T3 reads on X, hence T3 must come after T2. Hence the sequences T1, T2 and T3 which cannot be swapped, hence there is only one possibility. Now here's a different question. We have to find out wait for graph. That is, when an operation Ti is working on something and Tj has is wanting some resource data object, or the other way around, that is Ti is wanting some resource from Tj, then there will be an arrow from Ti to Tj. दैट मीन्स अगर टी आई को कोई डेटा ऑब्जेक्ट एक्सेस करना हो टीजे से, जो ऑलरेडी टीजे एक्सेस कर रहा है, तो हमें टी आई टू टीजे को एरो दिखाना है, रिक्वेस्ट का एरो जैसा तुम मान सकते हो. नाउ इन द गिवन सिनेरियो T1 is waiting for transaction T3 and T4. So T1 is waiting for transaction T3 and it is also waiting for transaction T4. T2 is waiting for transaction T1, T2 is waiting for transaction T1, and transaction T4 is waiting for transaction T2 and T3. So T4 is waiting for T3 and it is waiting for T2. This should be the graph, and from the given option D matches the graph, hence D is correct. Now in the next question, we are given two schedules. We have to find out whether they are recoverable and cascadeless. And for a schedule to be recoverable, if Ti is doing some sort of operation transaction before Tj accessing the same element, then Ti should commit before Tj. That is, Tj should not read any intermediate values which are inconsistent. That schedule is recoverable. So for both the schedules, the transaction that starts is committing before the other transaction committing. So in schedule 1, T2 is committing before T1's commit, and in schedule 2, T1 is committing before T2's transaction. Hence both of S1 and S2 are recoverable. That is correct. Now for schedule to be cascadeless schedule, that means if there is an error in T1, then entire T1 and T2, both of them will have to be rolled back. That is called cascade full. That is cascading transaction. We want opposite of that. That is cascadeless transactions. So for that to happen, we have to commit the changes. That is happening in schedule 1. We are committing the changes, and if there is any problem in T1's execution, we will only have to roll back T1 and not T2. Hence, only schedule 1 is cascadeless. So option C is correct. In question 9, we are given a log compatibility matrix. S means shared log, that is common log. So multiple resources can have shared log on a single data item. And for exclusive, that is X, only one transaction can use the data object. So when the case is true, that is when a shared object is requested a shared lock again, then it will be granted, else all the cases are false. So the option B is correct. That is, if a transaction holds S lock on data item, other transaction will not be allowed to obtain S lock on the same data item. We have to find incorrect statement, hence this one is incorrect. Others are correct from given matrix. You can see, for example, option A, if a transaction holds S lock on data item, other transaction will not be allowed to obtain a X lock, that is exclusive lock, because it is shared. You have to share the resource, hence it will not be allowed. That is correct. So only option B is incorrect. Now we have to find if the schedule is basically cascadeless or not. That is, we have to roll back how many transactions if there is any problem. Since T3 reads the resource Y, which is modified by T2 but not committed, so if T2 is aborted or failed, we have to roll back T3 as well, because T2 will be definitely rolled back, but it is reading some intermediate value, not a committed one. Hence, to get the latest value, T3 has to be rolled back as well. Hence, if T2 fails or aborted transaction, T3 must be rolled back, and T1, since it has performed a commit, it does not need to be rolled back. Thank you for watching. Subscribe the channel. Keep liking the videos.